morning, good afternoon, welcome to good afternoon, welcome to another section of C++. We're going to learn about pointers, arrays, and structures. Okay, so we learn about introduction to what pointers, pointers into arrays, references. Introduction to structures, introduction to what unions, introduction to enumeration too. Okay, so a pointer is a variable that stores what an address of another variable. Pointers can be used with any data type. So a variable that stores memory address of another variable is what we call pointers. Okay, here you see an example. A pointer can be declared in the same way as any variable, but with an asterisk or symbol. Okay, so we have another example assigning what address to pointers. The address of operator determines the address of any variable in C++. After this tutorial, we're going to run examples on pointers. The process of what accessing the value present at the memory address pointed by the pointer. And this is an example. Int with asterisk ptr equals end bar semicolon. See out what ptr. Yeah. Then we have differencing what a pointer. Difference of pointer, you use what asterisk to access the value at the pointer's what address. Okay, it's an asterisk to use an asterisk to access the value at the pointer's address. Then move on to modification of pointers. So can point point to another address of the same type. So modifying the pointer can point another address what of the same type. Here we have an example, classical example of it, of which we are going to also run an example code on. So modify a pointer address. This is an example of modifying a pointer address that what uses what the same pointer address. Now data sizes for pointers equal data size for all pointers based on operating systems and CPU architecture. 8 bytes for 64-bit system and 4 bytes for 32-bit system. This is how it looks like. Okay. Now move on to special types of pointers. We have the wild pointers, we have the null pointers. Okay. So wild pointers uninitialized holds what random addresses. It's uninitialized what holds random addresses. So wild pointers what holds what initialized random addresses. The null pointers point to no valid location. Okay, so you can have an example. Int asterisk ptr equals what now. Okay, then you move on to what void pointers. Pointers to a data of no specific type. Okay, it points to data of no specific type. That's what void pointers are. We have a dangling what pointer. It points to what freed memory. Freed memory. Now move on to what the reference. Reference works as an alias for an existing variable, providing an alternative name for it and allowing you to work with the original data directly. Reference with pointers. So a pointer allows us to pass potential large amounts of data around at a low cost instead of copying the data. We simply pass its address as a pointer value. Yeah. Then creating references. And is used to create a reference. So t and what ref is equal to var. Int x is equal to what 10. Okay. So now let's run an example code on pointers. Okay, let's run an example code on what's called pointers. So I open my text editor, which I'm using CLion. Then I'm going to write an example code. So here we're going to clear everything that is written here. And we are going to start what hashtag include stream. Okay, then using namespace std standard. Okay, we write our int name. Open our bracket. Now inside our bracket, we're going to visualize this code. So int a equals, let's say 7, then b equals 10. Close the argument. Now let's say int asterisk ptr equals what? And b. Let's use and a. Okay, let's use and a. Now close the argument. So C out asterisk what? ptr end the line, then ptr, sorry, ptr equals what? And b. Close the argument. So we see out asterisk ptr end line, then we are going to also move on to the size of talking about in terms of the pointers. So C out size of ptr, okay, then we want to end line, then we return return 0 with the argument, then we run the code. Yeah, and that's prints out the value 7, 10, and 8. So the 8 refers to the what? The size of the pointer. Then 7 and 10 represents the values of what? Integer a and b. Yeah. So we move on to creating what? References. Creating references. So someone said what's reference? It's an alias for an existing variable showing direct manipulation. JK syntax uses what? And see, syntax uses and. Example, int and what? Reference equals what? Var. That's what I said. Yeah. So application of references. Passing argument by reference int main. Okay, this is a classical example of application of references. So pass argument by reference to modify originals. Okay, so we use what? Application of reference to modify original what? Line of code. Okay, so returning what? Reference from what? Function, like int and get marks, int and a, int and a. Okay, so run an example code on this. You see you have your properties of references. You access a reference with exactly the same syntax as the name of what? An object. So you can run go and we make an example of how to call referencing. So let's say void main, sorry, let's say void main. Okay, then inside right? No. So let's void modify. Okay, let's void modify value. Put into bracket int and, okay, int int and x. Then you open the brackets. Okay, so inside the brackets, I'm going to put x is equal to, let's say, 12. Okay, now put our int main, then we open our brackets. Then inside we specify int x is equal to, let's say, 32. Excuse me. Now we say we are going to modify, yes, we're going to modify value x equals the argument. So cout cout x, end the line, then run the code. Okay, so there seems to be an error in void value 3. Okay, so we're going to instantly correct that. We're going to instantly correct that. Okay. Okay, so it's saying Okay, so we are going to modify the code since we are getting an error. So create this. This reference equals 20. So close the argument. Let's run this line of code. So initially we said that x was what 32. Then we modified it to what 20 as it should be. So the reference. Okay, so that is how you run code for what references. Now move on to arrays. Okay, we're going to move on to arrays. An array contains multiple objects of identical types stored sequentially in memory. Any objects in an array are called array elements. Array elements can be addressed using an index or subscript. Okay, so array stores multiple objects of the same type sequentially in memory. Okay, so declaration type like name size. That's example. That's you have. Sorry, examples here. Also have the initialization. You have the multi-dimensional arrays. Okay, see here comes to the index of arrays. And then initialization of arrays. I said you have the accessing with array elements. Accessing array elements refers to viewing individual array with items. That's the structure array name index. Okay. Then move on to the multi-dimensional arrays. Yeah, arrays with columns and rows. Two-dimensional arrays are data type here. That's the examples there. Now also move on to declaring 2D arrays. 2D arrays have both rows and columns and can be visualized as a table or matrix. And that's an example there which I'm going to put in a line of code. Declaring 3D arrays. 3D arrays have rows, columns, and that can be visualized as a table or a matrix. Okay, so let's go back to our line of code. Now let's clear all of this. Okay, then so we declare int main. Then we open our bracket. In our bracket, put our array. So let's put like 3. Okay, so 3 equals, let's say 10, 30, 50. Okay, so we close our bracket. So we say cout array 1. Then in the line of arguments. Okay, so declare int using the 2D what type of array. So declare 2 and 2. Okay, let's say equals 1, 2, 3. Okay, let's use 1, 2. Let's use 1 and 2. So let's close this bracket here. Then we say look at that bracket for, let's say, 3 and 4. 3 and 4. Then close the bracket, then end the line of argument. Okay. So we are going to see out. Sorry. I'm going to see out. What? 2D. 2D 1 and 2. 2D 1. Then 0. Okay. Then we in our line of code. Then we run it. Okay. I have a problem here. Trying to figure out what the problem is here. What could be the problem here? What could be the problem here? The problem is coming from the 2DR. The 2DR. Okay, let's say int 2D. Let's say 2, 2 is equals to let's say say 1. Actually, so let's say 1, 2. Let's close the bracket. Let's say 1, 2. Then let's say 3, Cout to the okay, there the code. Here is the outcome. This is the code we ran. This is the outcome. Okay, so we want to struct. Struct struct is a sequence of elements. Okay, struct is a sequence of elements of what element code members. Sorry, of arbitrary types. Used to create user-defined data types. So we have an example: struct name type 1, mem1, mem2. Okay. Then we have a struct example: struct address, constant char name. So we have also include iOS tree. That is the example code here. Now we move on to what? Creating a struct variable. After creating a struct variable must be created. Struct name var. That's the example below, which are going to include in our code. Creating a struct variable, and that is the example line of code. Creating a struct variable with definition. A struct variable can be declared with its definition. Struct name, that's for the type 1, mem1, type 2, mem2. Okay, that's the line of code. Another line of code. We want accessing what struct. This is an example of codes that we are going to run also our line of code. A struct member can be assigned using what the equal to operator. So assigning a struct member with the equal to operator, that is how you use it in the C++ language. This is another practical example of assigning a struct member. Okay, so we go to our text editor. Let's clean all this. Okay, and let's clean all of this. Okay, so let's say struct student. Struct student. Let's open the bracket. So let's say int age. Yeah, we say char, gender. Okay, so we'll move on to, let's see, so let's declare the int name. Now let's say student Eric. And let's say Eric dot age equals to 26. Okay. Now let's say Eric dot gender equals male. because I'm a male, not a female. So let's see out Eric.age. So that's Eric.age. Sorry. Use on okay. So Eric dot Eric.gender. Okay. Let's run this line of code for an example on struct. Okay. So there's a problem with Eric dot Eric dot gender, which we are going to correct right now. Let's try this. Let's turn that off. Okay, so there is a problem we are trying to solve. Okay, and output runs. So this is an example of using struct in C++ code. Okay, so let's move on to union. So union is a struct that holds the value of just one of its elements at any one time. At what? Any one time. So creating a union just like other user defined data type. You have to be defined before you can use it. You have to define it before you can use it. Okay, so move on to creating a union. There's an example of a code creating a union. So we'll do that after the tutorial. Then creating a union variable, a union variable must be created. Okay, that's also an example. Creating a union variable, that's an example of the code. Creating a union variable with definition. Creating a union variable with definition, that is also an example code. Then accessing what the union, as an example line code. Accessing a union member. The union member can only be assigned using what the operator equal to. All members share the same memory. Only one element can store a valid value. Accessing value through other variable what may lead to unidentified what undefined behavior. Means what, as we did earlier, junior.age equals 23. So this is practical like differentiating between struct versus union. So struct allocates memory for each member variable sequentially. The size of a struct is the sum of the sizes of its members, including padding for alignment. Members can be accessed independently at any time. Used to group related data of different types. Now union allocates memory only for the largest member variable. All members share the same memory location. The size of a union is the size of its member. Only one member can be active or hold a valid value at a time. It's used to save memory when only one or several members is needed at a time. Okay, so we're going to run a practical example on, then we'll come to enumeration and we end today's. So let us clear this. So let's start writing a line of code. So let's say union data. Okay, so let's say int now char ch. Okay, then let's close the bracket because I'm not a argument. Now let's write this int main. Okay, so let's say data d, sorry, data d dot num, let's say equals 45. So we see out d dot num see out d dot num, then the line argument, then d dot ch. So let's say d dot ch equals, let's say a, an argument. So let's say cout d dot ch. Okay, now let us run the code. Let's run the code. This is on union data. Okay, so this is how running a line of code on union unions looks like. So we head to our last topic, that is enumeration. Enumeration. So enumeration is a type with a set of named constant called enumerators. It holds a set of integer values specified by the user. The possible values are named and called word enumerators. Two types of enumeration: enum classes and plain word enums. It uses classes for defining enumerations. Enum class color like red, green, blue defines what an enumeration what called color. Okay, so plain enums can be unarmed. Unarmed plain enums are used when a set of integers, supposed to be integer constants, are needed rather than a type to use for variable. So this is an example of unnamed plain enums, which we are going to run in our line of code. Okay, so let us head to our text editor. Let us clean this line of code. Line of code. Okay, so let's see, enum class color. Sorry, let's say red, green, orange. Okay. Yeah, let's see enum small. Enum small. Enum small equals 1. Okay, let's say medium equals, let's say 2. Let's say large equals 4. Okay, so we close the bracket, we end a line of argument. Okay, so let's declare int main. Okay, so let's say color. Let's say color C equals color, let's say color green, and then an argument. So let's say we see out let's see we see out static, say static cast, static cast. Let's see green. Let's see, not green. And gold. Okay, so let's say C out, medium, and line, then zero, close, run our last line. Okay, let's see. I think we have a about here. Okay, slash one is called. Okay, so that is the last line of code for any variations. Thank you.